So first, ladies and gentlemen, join me in welcoming the Head of Innovation at Greenflux, Leonard Verheyen. Leonard, greetings.
Hi. Thank you.
I think you can stay here, otherwise it's
too many movements.
Yeah,
okay.
Unless you needed this seat.
I'm fine.
I will just keep quiet and sit in the corner.
Yes, that's okay. I'm not blocking the screen. Hi, good morning, everybody. My name is Leonard Verheyen, and I work as Head of Innovation for the company Greenflux. And today we're going to talk about energy system and electric vehicles. Now, I have to present the company I work for in about 30 seconds. But other than that, I will, then it will give you some framework to place my story in. I have 42 slides in 15 minutes, so hold on because we're going to go pretty fast. First of all, Greenflux. We are a company that, on one hand, services electric vehicle charging, and on the other hand, services the EV drivers. And that means that we have a platform that runs CPO business and EMSP business. So on the EMSP side, on the user side, we provide services like roaming, like payment, like invoicing, etc., etc. And on the CPO side, we make sure that asset management works, that the firmware is in order, that there's billing in place, and also, quite important, that we charge cars in a clever way, which is what we call smart charging, and which is what we will talk about today. There we go. To start with a definition of smart charging, there are many definitions going around. I'm not going to treat all of them. For me, smart charging is nothing more and nothing less than managing the power that we provide to an electric vehicle. We can ramp it up a little bit, we can ramp it down a little bit. Doing that, for me, is smart charging. The reason why you would do that makes it a little bit more interesting. How do we do that? We at Greenflux believe that we should connect every charge station via the internet. There's also another approach where you do everything locally. We do everything via the cloud. And we believe there's many benefits to that. For instance, that we can have charge stations of multiple suppliers into one system, that we have no limitation on the number of charge stations, that these charge stations can be located anywhere, and we can all smart charge them. Now, if you make the relation between smart charging, electric vehicle charging, and energy systems, you're basically talking about two things. And I'm going to treat both of them, which is a bit of a risk, because usually you should have in a short presentation only one subject. I'm going to have two because I think you can handle it. On one hand, we have to make sure that we don't overload the grid. On the other hand, there's a huge potential to balance demand and supply on a national level. I'm going to start with the capacity management, with not overloading, and then we're gradually going to transition into the power management. To start with smart charging on a basic level. This is like the lowest level. This is a situation that occurs a lot of times in public charging, where you have one charge station that has a grid connection, for instance 25 amps, and has two sockets that together take more than this 25 amps. 2 times 20 is 40, is more than 25. This grid connection won't be able to handle that. This charge station will manage this autonomously. Most charge stations, this is what you call local balancing. We don't need to intervene with that from Greenflux. It gets a little bit more interesting if you place a lot of those charge stations on one location. This is the location of one of our customers' customers, because we are a white label provider, so we don't install charge stations ourselves, our customers do. Where they have a parking lot with a 400 amp circuit breaker, which is quite high. And they want to have, actually they do have now 98 charge stations, all at 32 amps. So that's over 3,000 amps. If there are any electrical engineers in the room, you will know that that is a lot of power. You will normally not be able to provide that. What we do with smart charging is basically quite straightforward. We just make sure that everybody doesn't charge at the same time. So we have a situation on the left. Each block represents some power over some time. So that's a block of energy. If you have too much energy, you've all seen these pictures 1,000 times. We just redistribute this. And if you do that, you'll have smarter charging. And if you apply that, yes, in a real system, this is a view from our portal, and this is how it looks. Basically, we're just large children playing with little blocks of energy. If you apply that in this way, then we'll already allow you to charge about 5 times more vehicles on one location than you would be able to without applying smart charging. So it's pretty good. The question is, of course, can we do it a little bit smarter than that? And the answer, of course, is yes, because that was a leading question. Does anybody know what kind of cable this is? Sorry? Medium voltage. Very good, because there is no neuter in there. That is correct. I'll give you a prize later. This is indeed a medium voltage cable, and what it very clearly shows is that an electricity cable is actually not one cable. There's 3 cables in there, and this is what we call the 3 phases. And these electronically basically do not have anything to do with each other. So when we are charging on one location, we're basically not solving one issue, we're solving 3 issues at the same time. That's what we call 3-phase charging. Many times you don't care because a car is taking electricity from 3 phases at a time, so then it comes together in the car. But quite often there's cars charging on a single phase, and if you take that into account, it's actually very interesting. Here's our example that I showed you a few slides ago, and now I've split it out over 1-phase cars and 3-phase cars. And now you suddenly see that on phase 1 we don't have an issue. On phase 2 we have a tiny issue. Phase 3 there's no issue at all. So I have to intervene a lot less. In this case it would suffice to basically say this green one and this yellow one, I'll alternate them a little bit and I leave everybody else alone. And actually if a new car arrives and charges on one phase, on phase number 3, can just start them. And again, if you look at this in a screenshot from our real system, the system is able to detect which phase a car is charging on. And you see here about 4 o'clock, a second car is coming in. Initially it gets allocated power on all the phases, and then very quickly the system recognizes this is only a single phase, there's no issue at all. If you apply this, then it gets significantly more interesting. It depends a little bit on how much single-phase charging cars you have on one location. But I can double or even triple the amount of charge stations I can place on one location. So with this, I can have 10 to 15 times, 15 times is pushing it a little bit, 10 times more stations on one location. So we're getting there. This 3000 amps now suddenly only require 300 amps. So we're already set for this location. But I'm going to ask the same question, and again, it's a leading question. Can we do this a little bit smarter? And again, the answer is yes. Because this building is not a standalone, this parking lot is not a standalone thing. It's part of a building. And this building consumes energy as well. And we can take that into account as well. So basically, if the building consumes more power, then the vehicles get less. Truth be told, this is actually a different location, but it had nicer pictures. And what you see here is on phase number 1, we have a certain charge pattern. And basically, when the building consumes more, the vehicles get less. Same color blocks on phase number 2. On phase number 3, it gets really interesting. So for this location, without applying building optimization, there would be no charging allowed. An installer would say, well, you cannot have charge stations here. There's no spare capacity. And then it gets really interesting. Actually, I had an exclamation mark there. Another example of applying the same thing is this location. It's actually in the city that I live in, where we have a huge amount of solar panels. There's an electric bus charging, taking a lot of power. There's a tiny stationary battery, and there's 26 charge stations inside. And you see the same effect. We measure the building, we measure the solar panels, and it wasn't a very busy day, so we didn't have to constrain the charge stations. Basically, pushing solar panels inside, the solar energy inside the charger, or in this case, primarily inside the electric bus. How much gain you will have from integrating building optimization really depends on the building. If there's a very volatile building consumption, there's a lot of gain. If the building consumption is pretty flat, then there's not so much gain. So there it gets more speculation on how many more charge stations you... In the most optimal way, I would say 5 times more. Or in that case where otherwise it would be 0, it's infinitely more. In general, I could say it's somewhere between 15 and 45 times more charge stations. I think 15 is just the more realistic side of that. But still, that is a very significant improvement in how many charge stations we can place on one single location. And typically, this saves tens of thousands of euros, in some cases even hundreds of thousands of euros in installation cost. And also, you need a much smaller grid connection to the grid, which saves you a lot of money annually, so that you don't have to pay to a grid operator. Can we make this any smarter? Yes and no. We cannot squeeze more energy out of this grid connection. This is the max. We really take all the energy there is, but we can distribute it a little bit smarter. So we can say, well, all cars are equal, but some are more equal than others. We might say, well, there's a DC fast charger or several DC fast chargers that take priority over the AC charger, because in general, you are in a hurry when you use a DC charger. It could also be that there's a session with priority. It could be a charge station dedicated for charging an ambulance, for instance, or for the CEO. It could also be that somebody uses an app and say, well, normally you can just charge me at will, but today I'm in a hurry. And it's actually what we have in our white label app, that you can just press priority, and then we'll just prioritize your session over others. If everybody presses that button, the effect will be 0. Our experience is people don't use it if they don't need it. Initially, you play around with it, but then it's used in 1 or 2% of the cases, so that's completely fine. Now, again, this building is not in splendid isolation. This building is actually the street where the building is in. And if you zoom out a little, then there's a medium voltage transformer station over here that powers this whole block. So what you would want to do also is use the same technology and say, I have different groups of smart charging and I combine them into one group. And if you zoom out a little bit further, then here's the high voltage transformer station. This is actually the city I live in. So that's right at the top school, so that's the school of my children. There's a high voltage transformer and there's a lot of medium voltage transformers. So you can stack all these capacities on top of each other. Technically, we can already do this. We have an issue here. Well, the whole world has an issue here that grid operators are not legally allowed to give the proper incentives, but I'm hoping they will come. And if you zoom out even further, then you have a lot of cities, a lot of blocks. And at the end, we're not there yet, we don't have that many electric vehicles. At the end, you will be managing the transmission system, so the high voltage cables to not overload those. When we get at this level, it also becomes interesting to look at power management. I could talk about that for an hour. I see I have 3 minutes and 43 seconds left, so I will do it quickly. I will not spend an hour. But now we're getting, what I said, I warned you we're going to treat two subjects, so this is the second subject. We're going to talk about a little bit about power management. And power management is to basically balance demand and supply on a national level. And this is a whole different ballgame. It's really precise. Every second the grid needs to be balanced. We should really have an exact amount of the same power produced as consumed. If we do not do that, we will have a blackout. If we're lucky, it's just a blackout in the Netherlands, but quite likely the whole of Europe will have a blackout because it's all connected. For that, let's very briefly look at power production. I'm taking the Netherlands as an example, but it's comparable in most countries. So what we have in the Netherlands, we have a bunch of coal and gas-fired power plants. We have some windmills to that, and we have some solar panels. And this is the situation as it is now in 2021. If we turn everything on at maximum power, we can produce in the Netherlands about 25 gigawatts. In Germany it will be more, but what I will show you next, it's the same relative numbers. What we will be going towards, and at this point in time in the Netherlands we have 10 million cars, we have 300,000 electric vehicles. Pretty good, percentage-wise. What we're moving towards, of course, is a completely renewable society. It still says 25 gigawatts. In fact, it will be a little bit more, probably. But this is, of course, a challenge because the energy is there when it's there. I cannot tell the sun to start shining in the middle of the night. I cannot tell the wind to blow a little bit harder because I need it. So it will be increasingly more important to use energy when it's there. Now, where electric vehicles come, it's very interesting. If we electrify all the vehicles in the Netherlands, that's 10 million vehicles times 10 kilowatt. That represents a total power of 100 gigawatts. That's 4 times more than we can produce today. Of course, that's only true if they're all charging at the same time, which is not true. But even if we can take 10% of that, that's 10 gigawatts of pure flexible power. And that's extremely important because if you look at flexibility, the absolute winner is electric vehicles. There's a lot of sources of electric vehicles, but if you look at flexibility, you have to look at the marginal cost. How much does it cost to have this flexibility? What is the impact? And what is the availability of it? And electric vehicles score very, very well in all these domains. Charging your smartphone, very, very flexible. It's almost very available, but who cares? It's nothing in power. Utilities, very flexible, have a lot of impact, very expensive. And also factories, you have to intervene in the production process. Stationary batteries, quite expensive still today. Could change towards the future. Heat pumps, always turned on in the winter, always turned off in the summer, so only have flexibility during autumn and spring. Electric vehicles score very, very well on all domains because people buy them anyway. It's a very bad investment. You buy something that stands around 23 hours a day, but people buy them, so it's there, it's for free. They have huge batteries, much larger than they actually need for the average daily commute. They have a combined impact of 100 gigawatts, and as I said, they stand around most of the time. So electric vehicles are the absolute winner when we talk about flexibility, and they hold the key towards balancing demand and supply in a renewable future. I showed you this picture before. We connect charge stations via a cloud, and this enables us, this should have been flipped, but let's go from right to left, to combine millions of 100,000, millions, tens of millions of vehicles into one so-called virtual power plant, of which we can control the power. If you would connect such a virtual power plant to a platform, who cares what platform, with very smart algorithms, then you can use this as an interaction with energy retailers, with balance responsible parties, with TSOs, with whomever is interested in using this flexibility, and you will have a very, very cheap way, very significant way of balancing demand and supply on a national level, which will be increasingly important in the future when we have a renewable society. So this is my last slide, so don't worry. This means that this is actually why I, 12 years ago, joined this industry, why I think that electric vehicles are the key enabler to enable a renewable society. And while we do that, we'll also make sure that we don't overload the grid. That's it.
Thank you very much. So, Leonard, you can feel free to pick any seat you like. And now it's my pleasure to introduce the other panelists who are going to be joining us. So from Costal Industry Electric, the product manager for charging infrastructure, Dr. Stefan Hell. Stefan, hello. There he is. Come on in. And we also have from entail, head of software sales, Rock Poteco. Rock, there he is. And also from Tritium, the vice president of sales for Europe, Michel Scholtes. Hello. Welcome, gentlemen. Okay, so I think I'm going to just start off our conversation with kind of a silly question, but I bet there are people out there who are concerned about this. Leonard was sort of hinting at this, that it could be a possibility, but if we do see a transition to electric vehicles, will the electric power grid collapse? Should we be all afraid? Like, is this really a thing that people really have to be scared about? I don't know, maybe that's a question for Stefan?
I can start.
Yeah.
I think all the guys have similar.
Should we be afraid?
No.
Okay.
Definitely.
Okay.
Definitely.
Okay. So we don't have to be afraid,
No,
but what do we have to think about?
Leonard gave a very very good intro into the smart charging approach, and I think the market. We when I speak about the market, we are considering this right from the beginning. Means that it was always the intention not just plug in something which is a consumer, but also manage it in a certain way. And starting from the local part, from a single household, from a single flat, from a single parking spot, there the transition has to start in terms of smart, in terms of digital, and then of course it's going up into the grid situations. So, and that means we need to focus on the whole ecosphere in terms of smart energy management, and that's what I think we are here for.
Somebody else want to add something to that?
I am a little bit worried, to be honest. I agree with what was just said, because technically we shouldn't be worried. We can solve this with the technologies that we have available today. I am a little bit worried that regulation and grid operators making up their mind on how they want to solve this isn't going to go fast enough. What I'm afraid of within the Netherlands is that within a few years we could end up in a situation where grid operators have no other means to control this than say you can no longer place a charge station unless we tell you it's okay. And that's, we can still solve it, but we have to fix the regulatory part, and that's not going as fast as I would hope. So that's.
I can also agree with this, and we can also say that if we do it in a smart way, we don't need to be worried. So it's really the key issue is the connectivity of the chargers and the smart logic on the charger. Like Leonard, you made a really good intro what smart charging is. I like it. So we are, let's say, on the same nominator in this regard. So if we do it in this way, I don't think we have an issue. But it's still, definitely regulation is a topic, because if the markets are not regulated, there is still a trade-off between the equipment costs and, let's say, the minimum requirements about the connectivity, OCPP, and so on. And if this will not be solved, in some certain markets there can be some issues with the mass adoption of EVs.
Right, and I think all of this cannot be separated with the transition to cleaner energy. I know that on the entail website, I really like that. It says EVs are only as clean as the energy that powers them, right? So it doesn't help anybody if we're using coal-powered power stations to fuel electricity for an electric car. I mean, it completely defeats the purpose. So maybe we can actually talk a bit about this kind of smart energy integration? Like how, like what exactly does that mean? How is it smart?
Yeah. So first we need to look at on the location level, because there, let's say what Leonard already said, everything starts on the location, and if it is performed okay on the location, so let's say that chargers are interacting with the vehicle, with the location limitation, with the user, because every user has its requirement to recharge the car, and at the end also with the grid, then this is smart and it is interactive, because charger interacts with the user, it interacts with the building limitation, and at the end also with the grid. Because on the location there can be also surplus of energy production. So if everything works together in a smart way, this we call it also a smart energy, and smart charging.
Yeah.
So
we often look at the use cases. You have different type of use cases. If you, for instance, look at what Tritium is focusing on the DC fast charging and the hubs, they draw an incredible amount of power. And the grid has its limitations, but there are smart and sustainable solutions to cope with that based on microgrid solutions, on battery solutions, and, for instance, solar production next to it to also handle these kind of peaks. And then next to that, I think also coming back to your first statement, I think we shouldn't underestimate really the growth of this EV market towards 2025. If you look at the amount of cars that we currently have driving around in Europe, there's 250 million cars. And if only 20% of those are going to be electric, there's going to be a huge amount of demand in electricity for these cars. And I think we're drastically underestimating what we're going towards. And that's why this whole sustainable solution and integration of chargers, grid, etc. is so important.
I would add regarding smart. It's one part of it you already mentioned, and I also have in mind what Leonard mentioned with regulations.
Yeah.
It's not happening only that EVs are coming to the road. It's also happening right now that everyone is interested in producing his own local renewable energy. And in my understanding, and also my company's understanding, because we are also doing PV converters, we're doing charging infrastructure on cars and on the offside. What we see is right now that demand is coming from multiple sites. So PV is growing, EV is growing, and we have to do it on a smart regulation way, smart management way at the site. Completely agree on you. That will be the first step. So you will produce locally, you need to consume locally. And then, of course, also integrate, and that's a trickle part because of regulations. Every country in Europe has different regulations. We have to find a way that it be as a regulation part as easy as it could be for the grid operators to also manage what is being not produced locally, also feeding back into the grid, and give them the benefit to work with this extra energy, I would call it.
Something else that you have already mentioned is the challenge of dealing with peak times when a lot of people are going to want to charge their vehicles all at the same time. So I guess this is where load management comes in. Can somebody talk about how important it is and what is the best approach for that?
That's not a straightforward question to answer. So the importance is very clear. If we don't manage that, we will need to triple the number of cables and transformer stations in every country and everywhere in the world. I don't believe there is enough copper in the world to do that. It doesn't matter what it costs. I don't think it's there. So that's the importance. If this is on what we call behind the meter, so in a building, whatever, it's easy. We'll do it because there's also a financial incentive. If you have to regard like a street with many buildings and manage that, then it gets more complicated. What I strongly believe in personally, actually have a background, I used to work for a grid operator, is that we should create what's called flexible grid connections. This is actually something that we already have in, for instance, broadband internet. You have a 100 Mbit connection, but it's managed all the time. You don't have 100 Mbit. I think we should go to something like that with a grid connection. And to make that parallel again, if I say, well, I want really 100 Mbit for my internet all the time, I want to have this guaranteed, and instead of 50 euros per month, I'll start paying 500 euros a month. I think we should have something similar for grid connections, where we say instead of having a fixed connection with a fixed, we will have some demand management on that, and for that you will get a discount for your flexibility. If we manage that in a good way, and this is also what my point was, where we lack regulations. Grid operators are not allowed to give such grid connections, nor do they all agree that they should have that. So, it's but yeah, that's a way. We need to incentivize it some way. Yep. Without incentives, nothing's going to happen.
Yeah, completely on with you on this. So there are different roles on the market. There are EV drivers, they expect to recharge the car. There is a location owner who wants to really recharge the cars, but still taking it to about the limitation in the location to not overload the location. And there is a grid operator who wants to take care that the whole system and the whole network is not overloaded. Yeah? And especially like you said, Leonard, there needs to be certain incentive to push, let's say, a conversation between the charge point operators and the grid operators, that they work together and that they find incentives how to enable to really do this flexibility in the charge point network, because like we have listened before, with plenty of cars on the road, this will be a huge consumption of electricity. And if we do not do it in a smart way, and if there are not incentives to do it, it will become a problem. But I believe we are on the technical side, we are really on the right path forward.
Just a very easy example for a grid operator, just offer flexible tariffs. Right? Saying, okay, we have a situation in the afternoon where we definitely know from planning there will be a high peak in a subgrid because everyone is coming home. Yeah. So the tariff will be high. What's happening if the tariff will be low during the night? So it has to come into everybody's mind, and I think this is happening right now, besides PV local production, if we are able to use flexible tariffs, and then it's going to get smart again. Smart and load management is a combination. And if you have that as a first approach, everyone is start thinking about it and is also behaving in the same way. Otherwise, they feel regulated, which is not. You have the discussion from last year regarding COVID. Nobody likes it. Yeah, but if you have a chance to offer this kind of incentive, yeah, it's correct, then we're going into the right way.
It's a little bit dangerous though, because it will work on the short term. But if we have dynamic tariffs just fixed, what we will do as an operator, we will push everybody, these 10 million cars, to the cheap rate, and we will create new peaks that are significantly higher than the ones. So yes, but we have to handle those tariffs with care.
And isn't that something that would only really work for at-home charging or at work charging, or possibly like in a shopping mall charging? But what about the public charging stations where, on the highways, like where it's about fast charging? I don't really think that's going to work.
It can work anywhere. The technology is there, and the chargers are agnostic to how you control them, basically using the standards that are available and the technology that's available. It's just you have to look at the time, you have to look at the capacity, and you want to make sure that the end user gets his car full based on his use case. If he has at home, he has more time. He's probably got 10 hours to charge his car, so you don't need a huge amount of power there. If you're on the highway, you want to go away after you finish your cup of coffee as fast as you can. So there's a balance in there, but within those networks, especially on highways, for instance, or charging hubs with huge amounts of power drawing, you can also look at how to balance that in a smart way without basically overloading the grid, plus having additional power available based on batteries or solar, or however you want to make sure that you can provide that peak at the moment you need it.
And what about this idea of on-site battery storage? I know that that's also being talked about as a way of smoothing out load profiles at charging stations. Yeah. Is that also a realistic option?
It will be a realistic option for locations where you may have limited power available, and that way you can provide this peak power at the moment you need it. And also, again, in combination with sustainable sources, you can trickle charge the battery using either solar or the grid when nobody is there, because also you have to realize that these charge stations are not always occupied all the time. There's high demand, there's low demand. So there's always a way with technology, and again, we're looking at DC side of business, and we really see also a solution for more DC type of solutions in the future, not only for the higher power, but also for the lower power type of solutions. We were talking behind the stage earlier that if you look at car manufacturers, they're starting to offer already AC chargers as a option on the price list. So this market is changing so rapidly all the time, and the technologies that are being invented helps in coping with these challenges.
On local areas, talking about houses, it's already happening. It's already demonstrated. So you will more and more people buying local storage systems, 5 kilowatt hours, 10 kilowatt hours, to use this exactly for that use case. And it has to scale up, for highway chargers. Of course, higher investment, but of course also higher revenues for the operators.
So on home locations, it's definitely already solved, and it's already a proven market because there is a surplus of energy. And if we are looking about the usual use case, so people are at work when there is really the high production at home, so when the sun is shining. So the energy storage, so battery storage at homes, this is already a big market, and the battery is stored for, let's say, the evening hours when the consumption is really taking place. And here the car is only, let's say, additional battery, let's say a huge battery, because we see 50 kilowatt hours, 80 kilowatt hours, 100 kilowatt hours that is bringing to the location. And here it will play a massive role because, like you mentioned before, we see a huge, let's say, difference about the peaks, because in the daytime we have a huge peak, but during the nighttime we have a very low peak. And electric cars are really bringing to the market that we can stabilize this grid consumption, because if we do it in a smart way, we can push, let's say, the energy consumption and the EV charging during the off-peak hours, and accordingly also help to stabilize the grid.
I want to speak in a bit more detail about this smart charging, because something else, another term that gets thrown around in connection with that is bi-directional charging. So what's the difference and how do they relate to one another?
Maybe I can start. Because we are running a pilot now for 2 years together with BMW. This is a public project where we're operating 50 chargers in the field. And we use the battery of the car not only for charging and reducing peaks, but also using the energy of the battery to feed back into the house. First step, so vehicle to home, as we call it. And in the second step, and this is the good part, where we also integrate the grid operators into this pilot project, where we feed back energy into the grid. So someone could ask, okay, what is then the benefit for the user offering this storage for the grid operators? This is something we have to find out. This is an interesting part of the regulation and delaying game we're talking about.
There's a value,
Yeah, of course it's
Basically,
a value.
there's a value for the consumer who will allow his battery to be used for a certain percentage to also take energy from the battery.
Yeah.
And imagine if there's 20, 30 million electric cars on the road in Europe, you have a huge virtual power plant available.
So for the user, for the benefit, on a first glance, is he has additional storage energy for using at home. No one is using 80 kilowatt hours at home during the day. So the second usage is for the grid operators in a certain way to start thinking about how to stabilize their grid in terms of under voltage frequencies, reductive power, and something like that.
Yeah, there's one very important distinction to make in this regard. So we're talking about flexibility, and we're talking about energy availability. And when we talk about flexibility, then we need flexibility in the market. A power plant goes down, we have to solve it. We need flexibility in the system. When we just shut down 50,000 charge stations to compensate. The cheapest form of flexibility is just managed charging or not charging. That is always the cheapest. So in the merit order, so which form of flexibility am I going to use first? That's not vehicle to grid. Because vehicle to grid, you will have conversion losses. And it's simple. It's just the market doing its work. They will not pick the not cheapest solution. if you talk, and actually the volume of cars just controlled charging, well, I showed it for the Netherlands, it's 100 gigawatts. That's such a large volume that I'm wondering, when we talk about flexibility, whether vehicle to grid will ever get its turn. Maybe they will, but only after we've done all the managed charging. When we talk about energy availability, that's a whole different ballgame. Because in a renewable society, we will have energy primarily during the day and not in the evening. So then in the evening, we will need to go to the second best thing to get energy. And second best thing could be, well, let's fire up a coal-fired power plant anyway. Not the best thing to do, also not very cheap. Or let's have hydrogen storage, which is a lot of conversion. And actually then the next best thing is vehicle to grid. Because then suddenly those conversion losses are not so. So I'm a big believer in vehicle to grid when we talk about energy availability. When we talk about flexibility markets, I think we should focus a little bit more on just controlled charging, because this is where the biggest part of the solution will come from.
Yeah. I'm also on this point because, let's say, the biggest, solution that can be performed is just from charging to reducing the charging. Here we can really contribute a lot to the grid, because helping them to really stabilize and to shave the peaks. But bidirectional charging and returning, let's say, vehicle to the grid or vehicle to home, whatever we call it, is of course going to be a challenge, and there are certain constraints and questions how to do it. On the technology part, yeah, it is already available, especially on the DC. On the AC, there are still certain projects running. But at the end, are users ready to do it? Because first of all, they want to recharge their car, they want to have their batteries full. Are they ready to return the energy to the grid? Will they need to allow it every time the energy wants to go to the grid? What is going to be the price for this? Are they going to allow because every battery has certain life cycle, and the life cycle decrease based on the basically recharge cycles. So it is important, because if we are seeing also here battery degradation, are users ready to allow it to trade off among the energy price and discharging the battery? So it's still a lot of questions here. Yeah?
Well, why don't we think about just a typical company, let's say, and they're looking for like a company in the electric vehicle industry. It needs a complete software solution. So how could then smart charging be integrated with maybe other technologies so that the business can actually just manage all of their own charging networks? Like, how would that all work?
Yeah, well, I would say leave it to us. No, smart charging is never a standalone thing. So in Greenflix, I'm happy to work on smart charging, but I couldn't do this without the help of all my colleagues, because you cannot have smart charging on charge stations without also being able to manage the firmware, without also providing roaming services on this platform, without also providing invoice. You need everything, and actually it's more complicated than that, because most of our customers are large utilities, large companies, and they say, well, you're not going to take over our CRM system, you're going to integrate with our CRM system. You're not going to take over our invoicing system, you're going to integrate with it. So we need to have a full suite of services that integrates with everything. And then, yeah, whatever companies can already do themselves, they should do themselves. And we, as newcomers in the market, and I'm pretty sure that Israel is doing exactly the same, we have to fit into that ecosystem. And we do that by providing modular services in a very clever way.
I would like, to add one point, because that is not mentioned here, because you're talking for a standard company. They don't operate charging spots only or charge spots only. So you have to integrate, and that's what the point I would add on. You have to integrate this smart charging capability into the smart energy management system on a local base. Means they're also probably running heat pumps. They have other power consumers you have to integrate into a technical management system on a first glance at site, to be sure that you have all in mind, not only the charging events and the charge points, but you have to manage all the energy consumers in that area. And this is a mix between remote control and local control, which I think, in the end have to fulfill. I can't remember of a system like Greenflux also managing heat pumps or something like that. Yeah. So that's the part where it's get a little bit tricky, and I think this is also the part where we still have some limitations, because in the end, the customer, the owner of the company, wants to have a single key solution, I would call it, and this is still in a struggling phase where we have to find solutions, also on a technical base sometimes, to make sure that we're not exceeding his expectations.
there are plenty of professional solutions and tools already on the market. Let's say some tools managing heat pumps. There are tools like we have it also with the Green Flux that managing the charging stations. There are CRM system, invoicing systems. So it is important that these things can cooperate together, to have it integrated with the open APIs and really to work together in the harmony. So we believe more in this regard that it will stay that there will be professional systems, but they need to work in a harmony together.
I think if you compare it to the way internet started 30 years ago, we worked with these modems, and you had to make a telephone call, and you put it in there, and everything went very slow.
I think there are people here who don't remember that.
That's how it worked, really.
Yeah. When the dinosaurs were still
and this is I'm not a technical guy, so this is a market of hardware, software, and you basically need to have everything that everybody mentioning here to let them talk to each other. And when you have stuff talk to each other, you can manage it. And that's basically how simple it will be in the future. Now it's all new, it's quite complex, but that's what will happen. The way we use internet now, open up your phone, turn on your computer, it's there. And that's what we'll have in the future, I think.
So then what are then at the moment the main limitations of smart energy implementation?
I would call
well,
a summary of
one already.
It's a summary of what just mentioned. There is no standard protocol to talk to each other.
Right.
There are local regulations which we have to fulfill. For example, if you want to feed back into the grid in Germany, you have to fulfill other regulations as you do it in the Netherlands or in Slovenia, for example. And this is, or take the 15118 ISO standard, which at least is established to communicate between the car and the charger. But this is just one part of the whole ecosphere we have to fulfill. And to overcome this, I mean, the standard is in the field for more than 10 years, and we're still working on it to establish it in a proper way. And this is the part where I see a lot of limitations. Integrating energy management systems, local energy management systems, also, they have their proprietary protocols. They don't talk to each other in a more way. If a Volkswagen or a BMW, where they want to sell cars into the market, they want to make sure that the car is charging and be managed in every country of the world. And this is still the part where we have to do some work.
I think there's one other big blocker, and actually this is a very good stage to mention that, because this is where we can solve it at Hubject. It's absolutely crucial for the success of smart charging that we involve EV drivers. If EV drivers know smart charging is going on, but they cannot influence, nor do they know what's going on, then everything that goes wrong is due to smart charging. They didn't plug in the cable correctly, smart charging screwed up my charging. They used an invalid charge card, that is due to smart charging. So we really have to involve the end user. I showed, in one of my slides, I showed an app where we enable the user to say, I'm in a hurry, I have a high priority. This works if this is a user using a Greenflux white label app charging on a charge station that is powered by Greenflux. If this same user is charging on an entail charger, or if a user of us is, a entail user is charging on one of our chargers, we cannot have this interaction because this is a roaming situation and we have to communicate via standardized roaming protocols. And within those protocols, there is no message saying my user is in a hurry. It doesn't exist yet. I know there are developments within the open intercharge, open charge point interface protocol. The competing standard is the open intercharge protocol. I would employ everybody to spend a lot of attention on incorporating smart chargings into roaming protocol because it's the single most important thing to do in order to involve EV drivers into smart charging. Yeah. And if we don't, it won't work.
Completely agree, because when we are using, let's say, the chargers operated by one system, there are already advanced solutions available. But when we go through roaming, there are certain limitations already, and we cannot solve everything to this. Yeah. And one challenge that is also very important, it is really at the low level or the low-hanging fruit, is the connectivity of all chargers. So not only public chargers, but also workplace and home chargers or private chargers. And we are able to, if we are able to connect all the chargers to monitor, to control them, and at the end also allow smart charging and flexibility, this is the way to go for the smart charging.
We have about 15 minutes left. Why don't we have a look at some of the questions that have been coming in from our audience. So again, just to remind everybody, you can use the, hello online audience, hello. You can use the Mentimeter tool to send us your questions for any of the panelists or the keynote speakers. Don't be shy, there it is again. Use the QR code and send us any questions or comments or jokes or ideas. All right, so let's take a look at the first question that we got, which is, what will be the value for an EV driver? We were just talking about EV drivers.
Yeah.
So what will be the value for an EV driver to balance the electricity grid? What's in it for me?
Yeah, I think if you look at that, there could be two very important reasons. One is to get his car charged faster, because he basically can make use of a charge station there. If you wouldn't be able to oversubscribe, let's say, the power grid, you would not be able to connect and you would not be able to charge. And the second reason is also to basically allow more people to plug in and be on that, let's say, that grid that is being balanced. So in the end, the user gets faster and more.
Yeah, or just go into the incentive discussion, saying what is the benefit for a user? An incentive. As soon as he receives money, he's very open in terms, of course, we have to talk about other technical smart issues regarding the battery of the car. But in the end, they are most interested if you have an incentive coming back, or as could be something on money based, but also on another benefit like faster charging or priority charging, then you're on the right spot.
Yeah, exactly. We also have projects where exactly such an aggregators, let's say, and the CPO behind allow the flexibility and try to incentivize user to do the smart charging, so they are, let's say, rewarded for this. And they can be rewarded in terms of a lower charging costs, or they receive the money back after the charging session is completed if the charging was definitely also involved in the smart charging, let's say, flexibility.
Yeah. Yeah, all agree. So either you pay less for more service, or you pay a little bit less for, or you pay the same for more service, or you pay a little bit less for providing flexibility. The interesting thing is, we did a lot of research into this. Yes, price incentives are very important. They are the main driver, very closely followed up by I want to do well for the environment. This is also quite a problem. The interesting thing is how much cheaper it should be seems to be, from the preliminary research, completely irrelevant. The fact that it's cheaper is enough motivation. We've done research with people who had turned on their washing machines in the night because they had day-night tariff, and we asked them, how much cheaper do you think it is? Absolutely no idea. Then we looked into the data. They didn't even have day-night tariff. So that just the thought that it was cheaper was enough to motivate them. And
people in Germany believe also that if you put the washing machine on at night, it saves you lots of money.
Not all.
If they do really well, they might save €1 or €2 a year,
right.
probably. But just the thought we're doing the right. So
we're all psychological beings, after all.
Yeah. So how much money is it going to be? I have absolutely no idea. I think this is a commercial discussion.
There's a lot of lease companies on the road, and to be honest, do they really care about what they're saving? They want to get their car charged as fast as possible. And that's what you can do by managing the load.
Okay, let's take a look at the next question. Someone is asking, what is the revenue for the end customer when smart bi-directional charging leads to faster degradation of his or her car battery? Yeah, we mentioned that as well.
Yeah, first of all, it's not pretty clear to me in which way really degradation is going to happen. I'm in mind of some projects in the past where it was clearly proved that the usual aging of a battery is worse than the degradation of these bi-directional charge and discharge events. Usually these events happen on a low scale in terms of power, and using in a certain range of the battery, using this range to offer bi-directional, that doesn't have a really effect on the degradation. So in the end, the final question is, what is the revenue for the end customer? And this is something we already discussed. It's not clear for me right now in which way the grid operators, as on one hand, will offer these kind of revenues. On the other hand, it's an interesting part that also the OEMs, who at least for the first 5 years, give a warranty to the battery, they think about, I want to have also some benefit of that. And this is the discussion we're actually in. This project I was talking on the beginning will help to get a better understanding, like others are doing it. So, and we hope to get answers within the next 1-2 years when we believe first volume cars will appear on the market, which are at least offering certain bidirectional capabilities.
Yeah, and also we should realize, so I do believe there's a future for vehicle-to-grid, but at the moment, apart from some small-scale projects, the chargers are too expensive, the regulation is not there, the standards are not supported, both by the chargers. It will be another 4 or 5 years in an optimistic scenario when we have a mass deployment. There is so much research being done in converters into batteries. In 5 years, a lot will happen, and I'm pretty convinced that this battery degradation is a non-existing discussion at the time.
We probably know the value of the degradation, and the compensation for the end user should be higher than the value of the compensation, and award him a little bit for his flexibility. And that, I think, in the future, we can value that much better than we can do it now, because there's so many questions around it still.
So you just mentioned regulations. Our next question is about that. Someone is asking, can we bypass regulators and grid operators and build a system without them slowing us down?
Yes, we can.
Yeah, well, we can, but not in the economic reality that we live in. So we can just start applying it as Greenflux. We have public charge stations, and our customers have public charge stations that they want to do us to do smart charging. But in the end, yeah, if we start, or our customers start supplying services that cost money, because it's not a lot of money, but it costs money, for which there is no return on investment whatsoever. It's unfortunately in the economic reality that we live in, the answer has to be no. So even though that's my personal frustration, technically we do not have an issue here, but
right.
Yeah,
and it's exactly as Leonard was saying. As soon as you start at least installing something, you have the regulation on the door knocking and asking for feedback. So yeah, that's the situation we have to deal with.
Yeah, we do see, however, and we look at that in the DC microgrid development type of solutions that we offer with our DC chargers. And again, if you have everything on DC charging, DC storage, DC solar, have that in a microgrid, and especially when you have companies with big hubs of cars, could be an interesting solution to look at.
Also, from our opinion, is that at least in e-mobility, sometimes market leads the development, and then the regulation is coming behind. And also here in smart charging, I believe this will be the case. But yeah, we will see how fast they will provide the regulations.
All right, we have another question. Someone asks, how do we get the SOC level of the battery information?
state of charge.
State of charge.
State of charge, yeah.
I think there's 2 answers to that.
There's no car manufacturers here.
Why?
Well,
I can answer because we're doing the OBCs as well.
No, there's 2 answers. So there's the technical answer. The technical answer is you can either ask the user. It's not very reliable. Users don't like that. Or we can get it from the car via, you mentioned it already, via the new ISO 15118 standard. ISO 15118 basically says there's more communication between the car and the charger. It's not supported very broadly, but I'm convinced it will come. The more important question is, or the more important thing to mention is, we should not overestimate the value of the state of charge in smart charging. Because it's a very, very dangerous assumption to assume that somebody who has a 90% state of charge is not in a hurry. I was at a meeting, I had to drive from my home to a meeting to the south, half an hour. I was there for 45 minutes, then I had to drive to Amsterdam, and then back home, and I couldn't charge in Amsterdam. So I arrived there with a 92% state of charge, but I had to charge to full, otherwise I wouldn't make my daily commute. I would really not like somebody saying, well, this guy has a 92% state of charge, so don't charge him.
But
so
then you have your button.
Yeah, well,
you have your app.
State of charge information is only valuable in combination with knowing what a user wants to do. And that last part is very, very hard because users are unreliable. So yes, state of charge is interesting. Knowing it would make our algorithms like 5 or 10% better, but definitely not 50%.
Well, yeah, on the state of charge, we already received this information on the DC side, on the DC chargers. Well, there is, let's say, on the AC, still ISO 15118 that is coming that will also bring this information to the systems. But at the end, like you said, state of charge will not tell us a lot, because the exact information that we will need for the smart charging is the required energy from the EV driver, and this will be the case. Yeah.
So we have another question. Someone is asking, can battery swapping be a viable integration to smart charging?
It depends.
So obviously
It's been tried before.
Depends.
We all know the developments with Better Place that didn't turn out so well because there couldn't be an agreement on a standard. And that's what you need. You need a standard in order to be able to swap batteries. So for fleets, private fleets could be a very viable solution. For just random consumers, I think it's difficult.
Well, if car manufacturers all work together on the standardized solution, yeah, this can be the case. But if everyone installs its own infrastructure to swap battery swapping, it will be a huge investment.
It's happening right now on the two-wheelers, so that makes sense. But on four-wheelers, personally spoken, I don't believe in that. It was been proved in a negative way, because every OEM in the end, and that's the part who has to decide, every OEM is focusing on his optimized usage of a battery system, and swapping is not the use case they prefer.
What they said.
So our next question is, what will happen to offline wall boxes and dummy sockets already installed at a mass rate?
I think over the coming years, they will be phased out, because there is no real benefit in the future not using at least small intelligence in wall boxes. Take the incentive program here in Germany. Well, you got 900 euros for a wall box, which at least is capable of having some communication. I don't know other countries, I don't know the Netherlands, if that's the same. So the focus is quite clear that at least this consumer is being manageable in a very limited way. Yeah. And in the future, there will be no really big price difference between a dummy wall box or something simple intelligence. So there is no reason to install it in the future. Could be also happening that in the future dummy wall boxes will be more expensive than connected wall boxes, because the interested part, the grid operators, for example, have some interest in knowing what's going on.
Yeah, that's and also even without smart charging, with the systems that we have, our customers are able to solve about 95% of the issues with charge stations remotely. And if you factor in the fact that you cannot solve it remotely, but you have to send somebody to fix a charge station, then very quickly a connected charger becomes cheaper than an unconnected charger. And yeah, I agree with you. I think this is an issue that we have so many chargers, but if you look at the whole, that we still need to install hundreds of millions of charge stations, then those few 100,000 unconnected charge stations are not that.
I think the answer is really, really simple. If we make this a little bit interactive with the audience, how many people still have an old Nokia?
There's one.
There's your answer.
My son.
Everybody has a smartphone, right? So compared to telecom, we're going to go to smart charging stations, communicating.
It will also help to the user, because it will be able to provide more smart services. It will be able to optimize the charging scenario, because like also what we do on our hardware that we provide is that the charging station performs everything. So the charging station covers the 99% of the user needs. So the charging station learns behavior of the user, and accordingly also adapt and find the most optimal charging scenario for the user, even without connection to the system. But I believe this is also important. But the charging station really works autonomously on the location, really finding the best charging scenario for the user, trying to shift the charging into off-peak hours, and accordingly also, let's say, save the overall pricing on the energy consumption.
We have about 1 minute left, and I'll just ask the one last question. Is just quickly, would it be feasible to make people register to charging solutions even before they have an EV?
Of course they can. I just have, as I said before, our German incentive program in mind. So you can apply on a very easy way. It takes you 5 minutes. And then you have 9 months to install a charging solution and then get the incentive back. But usually there is no interaction between registering and using or buying. So it's up to them.
So everybody, thank you so much to our audience for all these fantastic questions, first of all, and thank you also to our panelists for an amazing discussion.
Thank you.
Appreciate it. Thank you.
Thank you.
So Lennart Verheyen, Rohit Poteko, Michelle Scholtes, and Stefan Hell. Thank you, gentlemen.
Thank you.
Thank you.
Pleasure.
Yes.
Bye.
Bye.